It is important to use the correct tool for the job to avoid damaging wires or causing injury. T-strippers are specifically designed for stripping wire, and they are the best tool to use for this task. Lineman's pliers can be used to strip wire in a pinch, but they are not as effective as T-strippers. One advantage of using T-strippers is that they are designed to strip wire without damaging the conductor. 2. They are easy to use and can be operated with one hand. 3. They are available in a variety of sizes to accommodate different wire gauges. Lineman's pliers, on the other hand, are not as well suited for stripping wire. They can damage the conductor if they are not used properly, and they are more difficult to use than T-strippers. If you are not sure which tool to use for stripping wire, it is best to consult with a qualified electrician. Consider the different types of wire strippers available and their specific application. Firstly, manual wire strippers, also known as T-strippers, are a common hand tool featuring multiple notches or holes of varying sizes to match different wire gauges. These strippers mechanically remove the insulation by gripping and pulling it away from the conductor. Secondly, automatic wire strippers offer a spring-loaded mechanism that clamps onto the wire, cuts the insulation, and pulls it off in a single motion. These are often faster and more consistent than manual strippers, especially for repetitive tasks. Thirdly, thermal wire strippers use heat to melt the insulation, allowing it to be easily removed. These are particularly useful for delicate wires or insulation types that are difficult to strip mechanically, such as Teflon. Fourthly, coaxial cable strippers are specifically designed for stripping coaxial cables used in television and data transmission. These strippers typically have multiple blades to precisely cut through the outer jacket, shielding, and dielectric layers without damaging the center conductor. When selecting wire strippers, several factors should be considered. Firstly, wire gauge compatibility is crucial. Ensure that the stripper can accommodate the range of wire gauges you will be working with. Using the wrong size notch can damage the conductor or fail to remove the insulation cleanly. Secondly, insulation type is important. Some insulation materials, such as PVC, are easily stripped with most strippers, while others, such as Teflon or silicone rubber, may require specialized tools like thermal strippers. Thirdly, ease of use and ergonomics are important. Choose strippers that are comfortable to hold and operate, especially if you will be using them for extended periods. Look for features like cushion grips and smooth action. Fourthly, durability and build quality is a factor. Invest in strippers made from high-quality materials that can withstand repeated use and resist wear and tear. Consider the reputation of the manufacturer and read reviews to assess the tool's reliability. In addition to wire strippers, lineman's pliers are another common tool used in electrical work. While not specifically designed for stripping wire, they can be used for this purpose in certain situations. Lineman's pliers are versatile tools used for gripping, cutting, and bending wires. They have a flat, wide jaw with serrated teeth for gripping and a cutting edge for cutting wires and cables. While lineman's pliers can be used to strip wire, it is important to exercise caution and use the tool properly to avoid damaging the conductor. To strip wire with lineman's pliers, carefully position the wire between the jaws of the pliers at the desired stripping point. Apply gentle pressure to compress the insulation without cutting into the conductor. Rotate the pliers around the wire while maintaining pressure to score the insulation. Once the insulation is scored, carefully pull it away from the conductor using the pliers or your fingers. When using lineman's pliers to strip wire, it is important to avoid the following. Firstly, applying too much pressure which can damage or nick the conductor, reducing its current carrying capacity and potentially creating a point of failure. Secondly, cutting too deeply into the insulation which can also damage the conductor. Use a light touch and gradually increase pressure until the insulation is scored. Thirdly, using dull or damaged pliers which can make it difficult to strip the wire cleanly and safely. Ensure that the pliers are in good condition and properly maintained. The NEC, or National Electrical Code, provides guidelines and requirements for electrical installations to ensure safety and prevent electrical hazards. While the NEC does not specifically mandate the use of a particular type of wire stripper, it does emphasize the importance of using appropriate tools and techniques for electrical work. NEC Section 110.12, for example, requires that electrical equipment be installed in a neat and workmanlike manner. This includes using proper tools and techniques for stripping and terminating wires to ensure reliable and safe connections. NEC Section 300.4 addresses the protection of conductors from physical damage. This section requires that conductors be protected from abrasion, nicks, and other damage during installation and operation. Using the correct wire stripping tool can help prevent damage to conductors and ensure compliance with this requirement. In addition to the NEC, other industry standards and best practices recommend the use of appropriate wire stripping tools. The National Fire Protection Association, or NFPA, publishes numerous standards related to electrical safety, including NFPA 70E, which addresses electrical safety in the workplace. NFPA 70E emphasizes the importance of using properly maintained tools and equipment for electrical work, including wire strippers. Furthermore, many electrical training programs and apprenticeship programs teach the proper use of wire strippers as part of their curriculum. These programs emphasize the importance of using the right tool for the job and following safe work practices to prevent electrical hazards. When working with electrical wiring, it is essential to follow safe work practices to prevent electrical shock, burns, and other injuries. Firstly, always de-energize the circuit before working on any electrical equipment or wiring. Use a voltage tester to verify that the circuit is de-energized before proceeding. Secondly, wear appropriate personal protective equipment, or PPE, including safety glasses, gloves, and insulated shoes. PPE can help protect you from electrical shock, burns, and other hazards. Thirdly, inspect your tools and equipment before each use to ensure that they are in good condition and functioning properly. Replace any damaged or worn tools. Fourthly, work in a well-lit and dry environment. Avoid working in wet or damp conditions, as water can conduct electricity and increase the risk of electrical shock. Fifthly, follow all applicable electrical codes and regulations. Familiarize yourself with the NEC and any local codes that apply to your work. Sixthly, if you are not comfortable working with electrical wiring, or if you are unsure how to perform a task safely, consult with a qualified electrician. It is always better to be safe than sorry when working with electricity. Consider the different types of wire insulation and their properties. Firstly, polyvinyl chloride, or PVC, is a common type of insulation used for general-purpose wiring. PVC is flexible, durable, and resistant to moisture, chemicals, and abrasion. Secondly, cross-linked polyethylene, or XLPE, is a thermoset polymer that offers excellent electrical properties, heat resistance, and chemical resistance. XLPE is commonly used for high-voltage power cables and other demanding applications. Thirdly, rubber insulation is used for flexible cords and cables. Rubber insulation provides good flexibility, elasticity, and resistance to abrasion and tearing. Fourthly, Teflon, or polytetrafluoroethylene, or PTFE, is a high-performance insulation material known for its exceptional heat resistance, chemical resistance, and electrical properties. Teflon is commonly used in aerospace, medical, and industrial applications where extreme conditions are encountered. The selection of appropriate wire strippers depends on the type of insulation being stripped. For example, PVC insulation can be easily stripped with most manual or automatic wire strippers. XLPE insulation may require more specialized strippers with sharper blades or thermal strippers. Rubber insulation may require strippers with a gentle grip to avoid tearing the insulation. Teflon insulation typically requires thermal strippers to avoid damaging the insulation. Consider the different wire gauges and their current carrying capacity. Wire gauge refers to the diameter of the wire conductor. The American wire gauge, or AUG, system is commonly used to specify wire sizes in North America. Smaller AWG numbers indicate larger wire diameters, while larger AWG numbers indicate smaller wire diameters. The current carrying capacity of a wire, also known as its ampacity, is the maximum amount of current that the wire can safely conduct without overheating. The ampacity of a wire depends on its gauge, insulation type, and installation conditions. The NEC provides tables that specify the ampacity of different wire sizes and insulation types under various conditions. For example, NEC Table 310.16 lists the ampacity of insulated conductors rated up to 600 volts, based on their size, insulation type, and temperature rating. The selection of appropriate wire strippers depends on the wire gauge being stripped. Wire strippers are typically designed to accommodate a range of wire gauges, and it is important to choose strippers that are compatible with the wire size being used. Using the wrong size notch on a wire stripper can damage the conductor or fail to remove the insulation cleanly. Proper wire stripping techniques are essential for making reliable electrical connections. Firstly, select the correct size notch on the wire stripper for the wire gauge being stripped. Secondly, insert the wire into the notch and close the stripper jaws firmly. Thirdly, rotate the stripper around the wire to score the insulation. Fourthly, pull the insulation away from the conductor in a smooth, continuous motion. Fifthly, inspect the stripped wire to ensure that the conductor is not damaged or nicked. If the conductor is damaged, cut off the damaged section and strip the wire again. Sixthly, avoid stripping too much insulation from the wire. The amount of insulation removed should be just enough to make a proper connection. Seventhly, avoid stripping too little insulation from the wire. The connection will not be secure if not enough insulation is removed. The importance of regular maintenance of wire strippers should be considered. Firstly, keep the stripper blades clean and sharp. Use a wire brush or cleaning solvent to remove any dirt, debris, or corrosion from the blades. Secondly, lubricate the stripper joints and moving parts. Use a light oil or lubricant to keep the stripper operating smoothly. Thirdly, inspect the stripper blades for damage or wear. Replace the blades if they are dull, chipped, or broken. Fourthly, store the stripper in a dry and protected location. Avoid storing the stripper in a toolbox or drawer where it can be damaged or exposed to moisture. When troubleshooting wire stripping problems, consider the following. Firstly, if the wire stripper is not cutting the insulation cleanly, the blades may be dull or damaged. Replace the blades or sharpen them if possible. Secondly, if the wire stripper is damaging the conductor, the wrong size notch may be used or too much pressure may be applied. Adjust the notch size or reduce the pressure. Thirdly, if the wire stripper is not removing the insulation completely, the insulation may be too thick or the stripper may not be designed for that type of insulation. Use a different type of stripper or adjust the stripping technique. Fourthly, if the wire stripper is difficult to operate, the joints may be stiff or the handles may be uncomfortable. Lubricate the joints or use a different stripper with more comfortable handles. In conclusion, using the correct wire stripping tool and following proper techniques are essential for making reliable electrical connections and preventing electrical hazards. T-strippers are the preferred tool for stripping wire, but Lineman's pliers can be used in a pinch. It is important to choose strippers that are compatible with the wire gauge and insulation type being used, and to maintain the strippers properly. By following these guidelines, you can ensure that you are stripping wires safely and effectively.